Hello, my name is Sam. This is the third video in a series of videos about GCSE maths. I am an online maths tutor, and this is a video all about completing the square, specifically changing expressions by completing the square and solving them by completing the square. This is a grade 8 to 9 topic, so it is on the harder end and will only be on the higher paper, but is a really useful skill as you can solve quadratics with it, and you can also find out some very useful information about curves as well. So let's get started. This is the graph y equals x squared minus 6x plus 1. And here is the graph drawn as well, and I've written out the equation too. So what is completing the square and what can it do for us? Well, let's have a look at this question over here. Write x squared minus 6x plus 1 in the form x plus a all squared plus b. This is the same expression I had just previously, and this time it wants us to write it in an interesting form. Now this is what completing the square does. This will allow us to take this expression and we'll turn it into this here. It will make it into this form, where a and b have a very special relationship to this expression and also the graph. So before I show what that relationship is, let's learn about how to turn this expression into the form that we want it in by completing the square. So we're going to start with our expression x squared minus 6x plus 1. And the first thing we want to do in completing the square is to get the x squared on its own. We want to have the coefficient of x squared be just 1. And that case is already true in this question, so we don't need to do anything. In later examples that will not be the case, and we will learn what to do then. But in this case we already have a 1 here, so that is perfect. The next thing we want to do is to make this just 1x. If you see here, we've got an x plus a squared. Again, if you expand this, you would get x squared plus 2ax plus a squared. Now we just want a, and so we're going to look for a half of what a is, and that is a half of minus 6. So we're going to turn this into x minus 3 squared. Now if we were to expand x minus 3, we would get x squared minus 3x times minus 3 times x plus minus 3 times x is minus 6x, which is great, that's what we've got here. But then there is going to be an additional plus 9. And then we can add the 1 on here as well. But that's not important just yet. So what we want to do is we want to get rid of this plus 9. This 9 is not in the original equation. So if we just do x minus 3 squared plus 1, that is not correct, as we have an extra positive 9. So what we have to do is we have to subtract the square of this number here. As because of this squared here, you will always be left with a double bracket, which has this number times by itself. So we need to subtract its square. It does not matter if this is a negative or a positive either. It will always be a subtraction, as a negative times a negative and a positive times a positive always makes a positive. So what are we actually going to do here? Well, we know that we've got an extra positive 9 from that expansion, and so we need to subtract that 9 and add a 1 on the end. We can then simplify this expression by merging the minus 9 and the positive 1 to make minus 8. And this is the form x plus a squared plus b, where a is equal to minus 3 and b is equal to minus 8. Now, what is significant about these? I mentioned that there was a relationship between this a, b and the original expression, and so we need to find out what that relationship actually is. And well, we've got minus 3 and we've got minus 8. Let's go back to our graph and let's see if those numbers have a relationship to this graph. And in fact, we can see that this point down here, right at the very bottom, is at the coordinates 3 minus 8, and that is the relationship that a and b have to the expression. It is known as the turning point. So the coordinate of the turning point of any quadratic, so any quadratic which comes in this form, which you have put into this form, has a turning point at the coordinate minus a, b. Now minus a is the negative of this here, so I'll circle this in red. So this minus 3 is equal to a, so minus a is equal to 3, so the turning point in this case is at 3 and minus 8. Okay, great. So that is putting this expression into the form x plus a squared plus b. Now let's have a look at solving a quadratic with this method. So here's another example, x squared plus 8x plus 5, and we are going to complete the square on it. So again, we need to make sure this 1 is by itself. There is a 1 written here, we just don't write it for some reason. But we need to make sure that there is a 1 there, and indeed that is the case, so we don't have to do anything to this expression first. Instead, we can go straight to halving this number. So we can get x plus 4, as 4 is half of 8, and square. We then need to subtract square of 4, so 4 squared is equal to 16. So I'm going to subtract 16 and add 5, and this is going to be equal to 0. So I can simplify this to be minus 11 equals 0. Now we need to find an answer to this. So because it is equal to 0 and we are solving, we want to find x equals something. That's the goal here. And we've got an equal 0 here. We've got some numbers and we're beginning to form a solution. So we want to try and get all of the x terms on one side. So we're going to have an x plus 4 squared, and that's going to equal 11. We can then square root both sides to remove this square. So we get x plus 4 equals the square root of 11. Now I've added a little gap here because I need to put a plus and a minus in here. Now if you've seen the quadratic formula before, this is spoilers, but if you've seen the quadratic formula before, there is a plus or a minus b squared minus 4ac within the quadratic equation, and this is where this plus or minus comes from. We're using it because there are two answers for x, so one where we are going to use the positive root 11 and one where we are going to use the negative root 11. And just to show that this works, root 11 squared equals 11, and minus root 11 is also equal to squared is also equal to 11, as a negative times a negative is a positive. So since both of these numbers, so since 11 square rooted could be either of these numbers, we have to include the plus or minus here. That is really important when doing completing the square, that you make sure to include that plus or minus. So then we can do x equals, and then we can subtract a 4 from both sides, so minus 4 plus or minus root 11. And if the question was asking for your answer in the form a plus or minus root b, this could be a suitable answer. Otherwise, it may ask for it as a decimal, in which you will have to put minus 4 minus root 11 into calculator and do minus 4 plus root 11 into calculator. And these will be decimal answers. Okay, so then if we're going to think about the turning point of this expression, we've solved it. We've got a value for x. These are our roots. So we have minus 4 plus or minus square root of 11. These are our two roots of our equation. What will be the turning point if we know this form? So we have x plus 4 squared minus 11. The turning point is at minus a, b, and this is a is 4. So we will have minus 4 and b is minus 11. So minus 11 goes there. Perfect. Let's move on to the next example. So this one is a little bit different. As you can already see, there is a 2 in front of our x squared. And I've mentioned it previously in the first examples that we need to make sure that this number is a 1. So this is an immediate issue that needs to be solved. So what can we do to make this a 1? Well, I could pull 2 out of the whole equation, but this 23 is going to be ugly. This is going to become 23 over 2. And we want to try and avoid fractions wherever we can. And since we're only caring about this x squared, we're going to only pull the 2 out of the x terms. So this is going to be 2x squared minus 6x plus 23 equals 0. This also makes our life a little bit easier, as after we do this, we're going to have to make an expansion that includes both brackets. And it can get complicated if you've done the whole thing in 2's or only part of it in 2's. So just make sure you only take that number out of the x terms. Leave the last term by itself. It just makes things a whole lot easier. So now we can treat this like the previous examples. We're not going to touch this 23, which we haven't done in the previous questions. We've just left the number here alone. We've only dealt with this x expression. So I'm going to do a 2, and I'm going to put a square bracket in here, as I need another bracket. So we are going to have our x minus a half of 6. So this is 3, and I can square it. The reason why I put this square bracket in here is because I now need to subtract the square of minus 3, which is minus 9, and then I close the the square bracket. Okay? So because I've done the factorization from here in only what's in the brackets, I need to preserve those brackets, and so I've turned them into square brackets, and then I've made a new set of brackets for my square term. And now I'm adding 23, and this is going to be equal to 0. This is a really common trip up point. People forget this bracket goes here. Sometimes they'll put it in here, and then it messes up the answer, because when you expand this, 2x minus 3 squared, you also have to multiply this number by 2. So it becomes minus 18 plus 23 equals 0. We can then simplify this by collecting our minus 18 and our 23. So this is going to become 2 times by x minus 3 squared plus 5 equals 0. Now, the 2 here is different from the previous examples that we've seen, but it does not change our turning point. So even though there is a 2 here, the turning point will still be at minus a, b, where a is equal to minus 3 and b is equal to 5. So this is at 3, 5 will be the turning point for this quadratic. Okay, so let's solve it. So we've got 2 times by x minus 3 squared plus 5, and this is all equal to 0. So I can move the 5 over to the other side by subtracting 5 from both sides. I can then divide by 2. I could square root here, but I'll be left with a root 2 in this position, and that's not ideal. So I'm going to subtract by 2 first, to have x minus 3 squared equals minus 5 over 2. I can then square root both sides of this equation to get x minus 3 equals the square root of minus 5 over 2. But hang on a minute. This minus has just made this question unsolvable. So even though I can now say that x equals the square root of minus 5 over 2 plus 3, this is wrong, because you cannot do the square root of a negative number. Unfortunately, this means that this question has no solutions. You can complete the square, you can find the turning point, but as when you get down to this half of the equation, you have to do a square root of a negative number. This quadratic does not have any solutions. Graphically, that means that the line for this equation does not cross the x-axis. If we have a look again at this graph crosses the x-axis at these 2 points here. In our version, our graph comes down to a coordinate and comes up without touching the x-axis at any point, meaning it has no solutions. You still may be asked to complete the square on a question like this, you just may not be asked to solve it, or you may be asked to say if it has solutions, something along those lines. But essentially this question has no solutions. So let's move on to our final example, 3x squared minus 6x plus 6. So first I'm going to pull a 3 out of here so that we have just a 1 in front of our x squared term. I'm going to go a little bit faster on this question. Sorry, I haven't put 0 here. I'm then going to deal with this. So I'm going to have 3, put our square brackets in, x minus 1 squared minus the square of this 1, which is just 1. I'm going to add 6, and this is going to be equal to 0. I can then expand this bracket to do 3x minus 1 squared minus 3. So 3 times minus 1 is minus 3. And I'm going to add the 6. This is all equal to 0. We can then do 3 times by x minus 1 squared. The plus 6 and the minus 3 become a positive 3 equals 0. Our turning point here is equal to minus a. So minus minus 1 is just 1. And then b, which is 3. and let's see if there's any solutions to this. So I'll rewrite this equation out here. Do 3 times by x minus 1 squared equals minus 3. Divide both sides of the equation by 3. Oh, that's not a 3, that's a 2. And then square root both sides of the equation. But uh-oh, we have a square root of a negative number. That is not allowed. This is not allowed, big red flag. So this question has no solutions or roots. But you can still find the turning point at 1, 3. Okay, thank you for watching. I've been Sam. If you're interested in online tutoring, please drop me an email. Thank you for watching.